We now determine the graphs which represents a one-to-one function. So for that, we can perform a horizontal line test on these graphs. So let's consider the graph in part A. So I'm going to use this blue horizontal line and I'm going to move it from up and down. So whenever I move it from up and down across the graph, this horizontal line should intersect at exactly one point on its graph. So suppose if I place the horizontal line here, it intersects the graph at this point, and now I take this horizontal line and move it up and down. So here it intersects the graph at this point. So likewise, if I move it from up and down, it should intersect at exactly one point on the graph. Then we see that the function is one to one. Clearly, the function in part A is one to one because it passes the horizontal line test. That is, whenever we move the horizontal line from up and down throughout the graph, it intersects the graph at exactly one point. So we see that the graph given in part A is one to one. Now let's determine if the graph given in part B represents a one-to-one function using the horizontal line test. So I'm going to take this horizontal line, move it from up to down, and I'm going to see if the horizontal line intersects the graph at exactly at one point. I can see that whenever I move it from up to down, it intersects at exactly one point. So at this point, it intersects. And for example, when I move it here, it intersects at this point. So and I move it down like this. So once again, it intersects at exactly at one point. So we can see that it also passes the horizontal line test. So we see that the graph given in part B also represents a one-to-one function. Now let's check the graph given in part C. So once again, I'm going to use this horizontal line. Before that, I see that this graph extends like this because we have a arrow here. So we can clearly understand that it goes like this. And now let me place this horizontal line. So I'm placing the horizontal line. I can immediately see that, okay, here is my line. I'm going to place this line over here. Maybe just a moment. Okay, so here I'm using a different horizontal line. This is showing up in black color. As I can see that I can place this on this graph and still show up this horizontal line. And we can clearly see that this horizontal line intersects the graph at exactly 2 points. So we see that this function is not one to one. This is not one to one. Okay, now let's do part D. Clearly, we can see that if I place the horizontal line on this graph, it intersects the graph at 2 points, that is more than one point. So once again, this is not one to one. Let's do part E. So I'm going to take this horizontal line, move it up and down, and see if it intersects at one point or more than one point. So far, it is intersecting at only one point. And still it is only one point. So throughout this graph, if I move it up and down, it intersects at only one point. So we can see that this graph is one to one. And finally, we do the graph in part F. So let me take this horizontal line and I put it here. And clearly, I can see that at this point, it intersects at more than one point. That is at this point as well as at this point. So we can clearly see that this is not one to one. Okay, so therefore we see that the graphs in A, B, and C, these are one to one, and the remaining graphs, that is, these are not one to one. That is the graphs given in C D, and F. This is not one to one. Just mention this has to be E, because the graphs given in A, part B, and part E are one to one. Rest of the graphs, that is part C, part D, as well as part F, these are not one to one.